welcome to Physics 12. So today we're just looking at half-life. So by definition, so we can define half-life as, let's say, half-life. We'll simply say this is the time taken for a radioactive substance to reduce to half over its original mass. So half-life is just the time taken for a radioactive substance to reduce to half of its original mass. That's the perfect way to define half-life. So just the time taken. For instance, if we have so just for easier understanding, if take for instance we have this element is decaying, so it means that if we have 1, 2, 3, 4, 5, 6, 7, 8. So the time that it is going to take to reduce to half over this nucleus layer, it is what is referred to as a half-life. So we have 8, let's say 8 atoms there. So if we have 4, so from 8 it goes to 4. 1, 2, 3, 4. So the time that is taken for this to reduce to 4, that's what we call half-life. So this time that it will take to reduce to a 4, it will be referred to as the half-life. So that's the way we can understand half-life, and the best way to define it is just the time taken for a radioactive substance to reduce to half over its original mass. So we know that time, it can be in seconds, it can be minutes, hours, it can be in days, weeks, years. So there is no data restriction there. So you just have to understand that. Then there are so many ways of finding half-life. So we'll start with what we call the graphical method, whereby we are given some values, then they ask you to find the half-life for that radioactive sample. So that's what you're going to start with, finding the radioactive, the half-life of a radioactive sample by using a graphic. Okay, so a good example of how we can find the half-life. You'll be given a table of values. We have time, then we have the count rate, or you can also put the mass. So it means that this radioactive started with this was the count rate, or the mass of a radioactive sample was this when the time was 0. Then after 5 seconds it reduced to this. Again after 10 seconds to this, 15 to that, then 20 to that. Then they ask you to find the half-life. The half-life of this radioactive sample, the time it took to reduce to half over this. We know that half of this is going to be 295. Half over the original mass is this. We know 590, then you just divide it by 2. This is what you're going to get there. So we want to know the time it took to reduce to 295. That's what you call the half-life. The time it took to reduce to is half, 295. The original was this. Then what time did it take to reduce to 295? So we can use a graphical method to determine the half-life. So what is important is just plotting these values. Once you plot the values, then we need to determine the half-life by finding half over the maximum there. Then we draw a line that will give us the half-life there. So the question says a radioactive source emits beta particles. So the count rate over which is on a scalar as follows. So this is what has been given. So the first question says plot a graph of count rate against what? Time. So it's just a matter of plotting plotting. Once you plot, then you go to the next question. So from the graph, find what? The half-life of this source. We need to find the half-life. So how do we find the half-life using the graphical method? That's what we are going to do. So we can say, okay, so after plotting the coordinates or the values that we've been given, we have these points. These are the points. After plotting, these are the points that you're going to get. So it's just a matter of now drawing a curve. So it starts from 590 there. Then you draw the curve. So it's supposed to be curve like that. That's the way it's supposed to be. Then it is not supposed to cut what? The x-axis. So this curve is asymptotic, meaning it cannot cross what? The x-axis or the where time is there. So it's asymptotic. So with that's the way the graph is supposed to come out. So it's supposed to be a curve there. So you just use what? Freehand what? Sketch. So it's very much important that you're not supposed to use what? The ruler there. No. Just use your free hand. Okay. Then the next question said, how do we find out the half-life? So once you have plotted the graph like that, how do we get to find what? The half-life. So step by step, for you to find the half-life, so you always get the maximum where it started from. So it started with this mass for the country. The original mass for the country was 590. So we are going to say 590 times half. What is half of this? This is going to give us 295. So after, so you get maximum. This is your maximum. Or for short, we are simply saying maximum times half. So this is what we get here. Maximum. So or the original mass times half. Original mass times half. This is what you are going to get. So once you find this number there, then you go on the graph there. So you locate now this number on the country. So 295. You locate it. So if this is 2, then we approximate there. This maybe somewhere there. 295. Then you draw. You're supposed to draw a line that is going to reach what? The curve. Like that. Then you drop it. So from there, it's supposed to go down like that. Okay. So this is your half-life. So you can simply say this is half-life. So we know that half-life is time. So you get your solution on time there. We need to find the time there. So from there, this is 5. Then obviously we can have 6, 7, then 9. So we can approximate there. This is what? 6. But when you're using a graph paper, it will give you the correct what? Figure there. So this is maybe 6 what? Seconds. So we'll simply say half-life. There, half-life is, so you get the value there. This is 6 what? 6 seconds, like that. So that's the way you can find what? Half-life by using what? A graph. So first thing you're supposed to plot what? The given what? Values. So once you plot, then you draw a curve like that. Then after you draw the curve, you always get the maximum or the original count rate or the original mass. Then you divide it by 2 or you multiply it by half. Since you are saying it's half of that radioactive sample. Then once you find this value there, you go back on the graph, then you locate this number that you have found. So once you locate the number, you draw a line. Then once it reaches the curve, you drop it until it locates you to the time there. So this is, in this case, this is what you have found there. So this was just one more finding the half-life by using a graph. So there are so many ways that you can use. So for today, we just wanted to look at the graphical method. Then in the next video, that's when we are going to look at the way other methods of finding what? The half-life. So I encourage you to find questions again. There are a lot of questions in the past papers with regard to the graphical method. So try to find those questions and solve them. When you fail, again, you refer back to the teacher. So you can ask, then I'll be able to respond. So for today, stay safe and make sure you're always not moving about. There's COVID out there. Thank you.